Here is an inspection of an office and warehouse space. About a 40,000 square foot building, office in the front, warehouse in the back. Office is probably encompasses about 5,000 square foot of the building. Rather than hitting every inch of this building as a walking commentary, I want to highlight all of the larger items and the most important items that an inspector is going to discover during their inspection, and some of the ways you're going to treat those during your inspection. We're going to try to highlight as many items of ComSOP section 6 as we can. Let's start with this exit path. We have an exit door right here. This exit door is locked. If there's any door in the path of the exit that's lockable, there needs to be a sign above it that says this door remains unlocked whenever the building is occupied. That's a very important thing, because if this door was locked from the inside to keep people from the outside from coming in, you can't get out in case of an emergency. Now, what's really fun is, yes, you obviously can tell there's no fire extinguisher here. There should be one. But what I like about this building, and we're going to come around the other side of this door, as an inspector, what's great to find is sometimes you're going to find a map of the building. This map is the emergency response map. It says you are here. So it'll tell you on the door exactly where you're at as you're coming in. Well, what I like about taking a map like this is I might take a photo of it. And by having a photo, and we're right here, by having a photo of this spot on my phone almost gives me a map of the footprint of the building. And I could use that through the rest of my inspection to keep me on track and to let me know where I'm at. This is especially poignant, especially important when I start looking at the HVAC, because most HVAC isn't labeled well. And by knowing exactly where I'm at in the building, I might have a way of figuring out which HVAC unit occupies which space. So walking through the building, as you're doing your inspection, your clients know that there's no flooring. So you don't have to put on the report there's no flooring. Your clients know that some of the walls have been damaged. You don't have to put on your report there's wall damage. You can. And I'm not going to tell you you can't do it. But you got to think that they should know those things as well. And I would, going through the building, we'll check outlets to make sure they're working. We'll look at windows. What we're looking at windows is obviously fogged windows. We don't have to identify the fogged windows that are so minute, but we're going to look for obviously fogged. These all look like they're not fogged, and so we'll move through those. We'll look at our ceilings. We see a large stain on the ceiling, so I would certainly remark and take a photo of that. That's going to be very important when it comes to the roof inspection, because that's an area that might concern us with the roof. If I had my map, I might even make a little mark trying to delineate, okay, it's 30 foot from that outside wall, and kind of get an area of trying to figure out of influence where that roof might have a problem. If we come into this conference room, again looking at the windows, if there were drapes, I'd move the drapes to see if there's moisture stains, but we do have an electric space heater. I'd turn the space heater on, see if it's producing heat or not producing heat, and make sure there's no receptacles over the top of the space heater. That could be an electrical fire hazard. And then we'll move space by space, testing receptacles, looking at ceilings, making sure that our sprinkler heads are occupying every room. We'd open and close a representative sample of the doors. And we go space by space by space. This is a great space for us here, because this will give me the opportunity to move back, to take a look. Nope, we don't have any failed seals here. Now I'm going to look on this side as well. Good. Now what's interesting on this building, this is a precast concrete building. And in the construction of this building, I've got the slabs that are stuck up on the wall to build the structure, and then I got the welds that are present. We typically don't get to see that in most construction, but this just is erected in a way and opened in a way that we can now see what's going on. So I like that. This is just going to be good for our video. Excellent. So we'll continue our trek through. That's a window, not a door. Now this is not a modern building. I believe this building was built in '84. So when we're doing our inspection, we got to think about exit. So if this is a room here, that when this door is closed, in modern configurations, an exit sign might be required on top of that space. It depends on how the building is rated. If this was an educational facility, for sure. It also might require emergency lighting, which is illumination that occupies the building when the power is out. So I would make a remark on my report saying I don't have an exit sign above this door, because I would think that's a door on this side. But in fact, it's a floor-to-ceiling window, creating this window wall. So that would certainly be something that I would consider adding, because from here, I do have emergency lighting here, and I do have an exit sign above the door. But in that room, it's a little confusing, and so that's something I might consider. In fact, that room used to be bigger. You'll see that this has been partitioned off to make that room even larger with this wall here. That's a false wall in between these two spaces. If you're doing your inspection, the only convenience outlet or receptacle we have in this room is located behind this door. So I'm not sure what this room was being used for, but whatever it was, that's the only receptacle we have, and it is behind the door. So that could be, again, something you want to make a comment on. I like to, as I walk through the building, shut the lights off as I go too, so I'm trying to be mindful of that. And that just makes things all that much, oh, there it is, all that much easier as we go. We're going to cycle through this way. We've got restrooms on both sides. And so on the restrooms, my typical procedure is to walk in, turn on the water. I have no water. So if that's the case, I will take a photo of it all. And if there's no water on, that makes my inspection that much easier. I don't have to note the functionality of the water. I will shake the toilets, make sure they're solidly secured to the floor. I will look at our stanchions and make sure these stalls are secure. It's amazing how expensive these are. And then we'll come into the shower room. Again, verify the toilet. Look at the shower door. Look at the tile. The door should always swing outward and never inward. And there should be a label on the door that indicates whether or not it's got a safety glass. It does not. So I would take a photo of the door noting that it does not have safety glass. And then we would move on from this restroom to the other one. I'm going to shut this water off so when they turn the water back on at some point it doesn't overflow. And knowing the water's off, I don't have to do any of those. We'll check our urinals. Again, shaking the commode, the toilet. If the water was on, we would flush a representative sample of the toilets, but we would verify that every toilet is free of defect, like cracking or etc. In this particular bathroom, our light bulbs aren't working. The door does open outward, but we do have some cracking and missing grout on the bottom of our shower stall. And so a comment about that would be very appropriate. And then from there we can move on through most likely the break room area. When it comes to this large open area, which is our break room, This is all the most common spot for the employees to congregate. And so again, we have a door. I know this is a vacant building. I know all that, but this is still a door that has been chained. And a chained door should be noted on your report. This does have the push out, so somebody can vacate the building, but the chain should be something that you place on your report for sure. Doors should never be found chained. Look for seals. Come into the break room area here. We'll verify the GFCIs are functioning. That one is functioning. Functioning. We'll hit this last one right here. Functioning. Whenever you trip a GFCI, you should make sure you put it back together so it's back functioning again. If you wanted to go to the minutia, you could absolutely comment on loose hinges on the break room doors. You absolutely could. It really depends on how you want to do it. Our ComSOP does not deal with cabinetry other than the fact it should be present. So absolutely consider commenting on it. That's up to you. Since we don't have any water, I don't run the appliances. So we do have a dishwasher here. We have a coffee maker there. The fridge has been vacated, and I'm not sure what would have been there. But we do have a disposal. I open up the sink. If we did have water, we would run the sink. If we don't have water, we're not going to run the sink. I am going to turn on the dish disposal. It does make noise, and that's where I'll leave it on that. Again, here's the housing for a fire extinguisher. If you were inspecting fire extinguishers, you would make sure that they're within date. Date should be 12 months to within the last inspection label on that. We have a water heater located here. With the water heater, I would take a note of, if this was on the second floor or above our head, a drip pan. This is not, this is on the ground, so it does not require a drip pan. This is an electric water heater. It's a 2012 water heater. It's a 50 gallon in 208. Here's our disconnect for it. Our disconnect does have the proper width and space for it, and the water is off on the water heater. So I can't verify its operation. We do have a pressure relief valve. That pressure relief valve does evacuate to within 6 inches of the floor. And so that's all I would identify with this water heater, is the fact that it's present, its date, and its location. We need to verify hot and cold water everywhere in the building. So wherever we have a faucet or a sink, we need to verify that hot water is present on every sink. Now, from here, we'd either migrate into the warehouse space, or we didn't see all of the office space because it's kind of built like a horseshoe. So what we want to do is I want to go back to the other side of the horseshoe and let's inspect the rest of the office space area. If you follow some of the procedures that we've put up, one of the more important aspects of a commercial inspection is your organization. And one of the best ways to stay organized is providing a preliminary walkthrough. I did a preliminary walkthrough on this building. I walked the whole building. That's why I'm able to tell you that, oh, we're going to find the break room next, and that's where we're going to find the water heater next. I've already identified all those during my preliminary walkthrough, and I've also identified this. Here are all of our thermostats that operate the building, and I've identified that that one's off, that one's on, off, 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 on. We are not required to turn on any device that's already off. So coming in here and taking this thermostat and turning it from off to on is well beyond the scope of our inspection. And in fact, you were not here when that was shut off. So your turning it on could damage the unit beyond repair. So your report should simply take, and if you wanted to, you could open each of these up, so that you can see that this is RTU 1, 2, 3, 4, 5, 6, and 7. And say RTUs 1, 3, 4, 5, 7 were all off. That's all you need to do on your report. And then do your visual examination of whatever's on the roof. So that would be my recommendation. When it comes to the inspection of RTU 2 and RTU 6, well then you can certainly come in here and make it from heat to cool or cool to heat. You can certainly rise the temperature up or rise the temperature down. These units are operating. And these units could absolutely have a test operation. But the rest of these other 5, I would never turn on. Now it's also interesting, if we come into this room here, this is our data room. Above our heads on the data room, we do have light indicators. Each one of those indicators is directly attached to the operation of one of the RTUs or heating units on the roof. Now what that does is that allows whomever's servicing the unit to know that there's power going to those. All those are off right now because we are in a state of power off, but that would be something that we can note of. Our first panel that we've greeted is labeled panel A. I verify that I don't have current, either with the back of my right hand or with a non-contact voltage detector. This will vibrate in my hand if I have power present. And in doing that, then I can open up the panel. What I'm doing, because I did a preliminary walkthrough, I know there are 12 service panels in this building. With 12 panels, I do not want to create an inspection report with 12 individual panel pages. So these panels are going to be placed on what I describe as a schedule. And the schedule is a listing of the panels in a spreadsheet. That spreadsheet will include the panel identifier, which is A, the panel voltage, or amperage, which is 225 amp, the voltage, which is 208, 120, the phasing, which is 3-phase, 4-wire, and whether or not it's labeled or not labeled. And so I will identify that, and then I might make a section on my schedule that talks about remarks. And my remarks would be any deficiencies. In this particular case, I don't have any. A common deficiency would be working space. In working space, they have here on this image as 3 foot by 30 inches by 78 inches, or the 30, 36, 78 inch rule. Now, beyond that, we have all of these other devices in here. I've got 4 more thermostats present, plus these 2 lab heaters that are present. This one's on, this one's off, that one's off, that one's off. So now we've got a total of 11 thermostats so far we've developed in this building. So that's something to keep in your inventory as you're up on the roof doing the inspection. The rest of this is all data. That's all beyond our scope. These are things that we don't concern ourselves with, other than the fact if there's a live electricity, which is what this is, whether or not it's properly secured and safe. In this particular case, we're running it off of that receptacle there, and that looks keen and safe there. So we'll continue to cycle. Wait, let's stop here for a minute. This is a vacant building. So let's see what we got going on here. That looks interesting, doesn't it? That's got a kind of a unique impression, a speckle, a spot that doesn't look the same as the rest of the wall. I think we're going to need to do some further investigation. That further investigation could include using a moisture meter. And in this particular case, I could put a moisture meter into the wall and see it's dry. Or, I know we got a building that's in disrepair. Let's take a look at the opposite side of the wall. Well, look at that. We come to the opposite side of the wall, and that sure looks like a bioorganic growth that might be mold. Now, I'm not going to do a mold test on this building because my client didn't ask for one. I could ask them if they'd like me to do a mold sample, and we could certainly send that away. But my report, I'm going to take a photo of it, and I'm going to talk about the bioorganic growth that's been found on this wall here. And in most cases, because this is a large vacant building, my guess is they'll cut the drywall out and replace the drywall with something that does not have mold. But now here we are. Now we're in the warehouse space and away from the office space. My inspection of this space is going to be fairly routine. I'm going to make a circle around the building, and I'm going to inspect the receptacles. I'm going to look at the plumbing as we go. I'm going to look at the ceiling and the structure. And I do that all at the same time. Our structure is steel column construction with steel truss beam construction and steel trusses as our roof structure. On top of the steel trusses, we have a corrugated steel decking, followed by probably a foam layer, and then the roof deck that's located above that. As we're inspecting all this area, I'm looking for openings, I'm looking for rust, and I'm also being conscious of the simple structural principle of plumb, level, square, and straight. This column here holding up that beam needs to be plumb. Plumb is a state of verticality. The beam needs to be level, which is a state of being horizontal. And then everything else needs to be square, which is making sure that we haven't moved. And then straight is like straight as an arrow, straight as the floor. And so those are the things I'm going to look for. And then I'm going to note for any differences that might be present. So going through, again, I try to find some logical path. My path is going to start here, and I'm going to encompass the building. We know this building is in a state of disrepair. We know the building has had some deconstruction to it. So you don't have to talk about, if you don't want to, all the missing drywall, all of those things, all the missing plumbing. You should talk about the safety issues that might be present. And so those will be what I'm going to concern myself with, but I'm going to look for the windows again. Make sure the obviously fogged ones are noted. So far, so good. We haven't seen those. Here's a door here. This door is able to be locked. This door should have had that sign across it that says, must remain unlocked during business hours. But you see what we see here? That exit sign has been covered over. It's very possible that they've rid themselves of this in the exit plan. I'm not sure. But at a minimum, I'm going to take a picture of that exit sign, and I'm going to note that it's not illuminated and it's been blocked over. It's almost as if this building was designed to be subdivided, and this area here would have been a separate entrance to a different tenant. But right now we're inspecting it as it sits, and as it sits, I have a door that leads outside without an exit sign. When we come over to this space here, this is where our fire department riser is. This is our sprinkler system. The water comes up from the ground and goes up through all of the sprinkler heads that are located around the building. Within this room, I've also got the fire department connector pipe on this side that goes outside. That's where the fire department can hook up and supplement the system. One of the key items in the plumbing section that we have to identify in every building is our backflow preventer. What we want and want to make sure we do is we don't contaminate the entire municipality by whatever we're doing in this building. And so our backflow preventer in this building is a simple backflow preventer located on this wall here. And on this wall is this simple backflow preventer, and this, if there's any backflow of water, we'll spit that water out down this pipe. And that's designed to make sure that any contamination does not go into the rest of the municipality. Beyond that, I've got a main water disconnect on the bottom. That main water disconnect is located right here. I've got another one right here. This is a pressure reducing valve. We have a high pressure water system in this municipality, so this drops the pressure to a usable pressure somewhere under 80 pounds per square inch is what the municipality likes to provide. And then the water is distributed through the building. What I love about inspecting plumbing and the water is the pressure is static. And so what I mean by static is, if there's a leak, we're going to see it. In this case, with the water being off, we're not going to see anything. But the interesting thing I see is all these valves are in the on position. So I'm not sure why the water's off. It's certainly not off in the building. So it's possible the water's been disconnected from the main. This is a vacant building. So at the main water source of the building is probably where it's shut off in the street. Again, we're going to look at windows and carry forward. But then when we come up to some of the vacated receptacles, again, missing an exit sign, is I've got a receptacle that's been vacated here, and the end of the wires do not have caps. And that end of that conductor, that wire, is in direct contact with the metal box. So if the power comes on, because let's just see here, I'm hoping there's no power. Nope, there's no power. If the power was turned back on that panel for this receptacle box, we're going to have an arcing and a potential fire. And so we want to make sure that there's a wire nut and a cap placed on that. Here's an overhead door. According to the ComSOP, we should exercise every overhead door. This is a vacant building. I worry about security. So I will take a picture of this door and note on my report that we are not inspecting we're not operating the overhead door for security reasons, verify that the operation, it doesn't have a mechanical opener on it. So we don't have to test that device. But I would look at the spring as well. So we saw the riser room for the sprinkler. We have a fire alarm system here. Now in the fire alarm system, again, it's an electrical device. 30 inches, 36 inches, 78, mandatory. Got to have the working space. But all we're going to really be mindful of is the power on and is it functioning? If I saw any lights on here that said trouble, then that's a problem. But when I see all systems normal, all we're doing is inventorying the presence of the alarm system and not necessarily inspecting the alarm system. The alarm system should be inspected by the authorities having jurisdiction, and certainly not us. Our job for the ComSOP is to identify its presence, and then beyond that, whether it's functioning. Now, we're in the electrical room. In this electrical room is a pretty complex room. This room is unique, and it's unique because I've got two giant pieces of switchboard equipment. I've got one on this side of the room and I've got one on that side of the room. And that's unique for this space because as a rule, we only have one means of disconnect for any building. But in this case, this building has two. And the reason I was able to deduce that is this piece of equipment here is 2,500 amps, 208 volts, 120 volts equipment. And this piece of equipment is 480 volts, 277, 1,000 amps of equipment. Usually when we have the one piece of equipment like this 480, 277, we use a transformer to step down the electricity to make the 208, 120 suitable for running receptacles and lighting. In this particular case, we do not have a transformer in this building. We have the 480 on this side and the 208 on this side. So in other words, to shut this building off, I need to disconnect the 480 on this side and the 208 on that side. So it takes two hand movements. Now, where my deficiency is, and the issue I'm going to place on the report, is it doesn't say that. If the emergency personnel show up to this building and there's a fire, they need to be able to shut off all the power and disconnect the building from the grid. and that would be shutting that side off and that side off. And there should be a note for that. But when we're looking at the rest of the system, I've got all these rest of the panels that will go on my schedule. This particular one is H1, this one is H2, this one is 480, this one is 480, this one is J, and this one is 208. So J is serviced by the 208 side of the service, and H and H2 are serviced by the 480 side of the service. I hope that makes sense, but what's most important as a commercial inspector is you've got to step back and walk the system. Now we're lucky enough in this system with all the conduit that's here, I can trace this large piece of pipe up over to the ceiling, make the bend, and have it fall down the wall and end up in this 208 panel. And the labeling on this 208 panel says panel J. So this is the means of disconnect for panel J. And I could do the exact same thing on panel H1. I could take this piece of conduit here, travel it up, travel it over, and it comes down into this box, and there's that H1 disconnect here. That box does not communicate with this box, and this box does not communicate with that box. So again, two means of disconnect for one building. When you're inspecting these boxes, we need to worry about the working space and the dedicated space. Working space in this case, I've got a grounded side, so I have to worry about that rule. And working space on that side, I have a live side because of these panels here. So I have to worry about that rule. Because this is 208/120, I can still remain 36 inches deep. But if this is 600 volts, then I have to go up to 5 foot wide or 5 foot deep on this. What we're worried about as an inspector is verifying that these panels have the proper overcurrent protection. So we mentioned panel J. And panel J was a 225 amp panel. And we mentioned the disconnect on panel J, and that's down here. And this is a 200 amp disconnect. What that means is that 200 amps is what shuts off that panel. So long as this disconnect here has a lower amperage than the panel that we're disconnecting, then our overcurrent protection is achieved. But if this disconnect amperage is larger than the panel, then we have a problem of overheating. Let me see if I can give you an example. I have panel H1 here. I have panel H2 here. H1 panel is 277/480, and it's rated at 250 amps. And our H2 panel is rated at 400 amps. Our H1 disconnect is 200 amps. And our H2 disconnect is 400 amps. If I found the H1 disconnect at 400 amps and it's providing the disconnect for a 225 amp panel, then we would have an overheating situation. That's what we're going to verify during our inspection. We've moved from the electrical back into another portion of the warehouse space, and when you go through the warehouse space, again, what did we see on the wall of the office space? We saw that there were, of the 7 thermostats, 5 were shut off. Then we went into the tech room and we saw of the 4 thermostats, 3 were shut off. Now when we walk around this space in this warehouse, I don't have a single thermostat hanging on the wall, which means all the thermostats are being controlled by one of those 11 thermostats. And so being not properly labeled or not labeled well, let's look at the inspection of some of the stuff that's here that we can do visually. I've got a hanging furnace here. On this hanging furnace, it's a larger than normal hanging furnace because it actually has dual fans that add for the distribution. This operates conically, pushing outwards. So it's in a weird angle where it's not heating any spot of the building, it's actually heating wherever that ductwork is that it's pointing at, which is unique. But when I look at the gas pipe of this hanging furnace, there's one element missing, and I'll pause for effect. What's missing is I do not have a drip leg on the gas pipe as it's suspended from above. Wherever the lowest angle is on the gas pipe, we need to have a sediment trap. And in this particular case, it would be right here at that elbow, on the other side of the union, or it could be over there, but I need to have a sediment trap. Without that, condensation or debris can go right into the control valve, and that's something we don't want to have. And so we're going to watch for that. I'm not going to test operate it because we got the thermostats are off, and on my report I think I'm going to simply say none of the HVAC was operated during the time of the inspection and just be done with it, and it's going to make our job a little bit quicker as well. But again, this is a unique heating apparatus because it was only designed to heat right here. One of the toughest things we have as an inspector is looking at this. And the only thing I have is it's a Dayton and it's a hanging furnace. My deficiency is the drip leg. My operation was not done because the thermostats. Now, if you want to go further, you could invest in a camera that provides you an adequate zoom to get to the label plate that's on the side. Most don't have that. And so in this case, I would probably not try to interpret the date or the size. But if you were able to get up there with a ladder or get up there with some form of telephoto lens, then you would be able to get the size and possibly the manufacturer date on it. But in my case, I would identify this as a Dayton. I would also, on this building with 11 HVAC units, have a schedule for HVAC as well. Just like the schedule I had for the electric. My schedule for HVAC would include the model, the age, the size, the location it's occupying, and possibly model and serial number if you thought that was germane for your clients. We have another bank of restrooms here. We talked about the water heater on the other side. Water heaters in restrooms can be probably one of the most troublesome parts of your inspection because they're not readily accessible or readily visible. In this particular case, for these two restrooms, our water heater is suspended up into that ceiling space. Having that water heater so high makes it almost impossible for us to get to. Now you can take a couple different interpretations to the ComSOP. First is all HVAC equipment that is not readily accessible or greater than 16 foot off the ground must have a permanent means of access. Well, that's plumbing, not HVAC. And so to get to that requires a ladder, which means it doesn't get serviced very often, which means it probably hasn't been seen in a while. It does have a drip pan. I know it's a drip pan because I do have this pipe that's exiting down from up on top and it comes down into here. But I would, in most cases, put my ladder up and try to get up to look at that. Plus I want to look at above. I do have another piece of heating equipment here that's very similar to the other Dayton. But again, where is this heating? Because it's not pointed to the space. My assumption is, and this is only an assumption, I don't have a client present with me. I was let in by the realtor today. I have nobody to talk to, so I'm going to write a report based on what's present. And my guess is that was installed during a previous iteration of the building. And all of this was installed subsequent to that. And those are left over from that previous use. And that's my guess, and that's what I would garner from that. And then we go through the rest of this building. Again, columns, plumb level, square and straight. Beams we're going to look for. But we also want to be very conscious of and this is such a bright space in here, our corrugated roof structure. That corrugated roof structure should be free of rust, free of damage, free of any impediments like that. One of the bigger things that can happen on an inspection like this is if we have any type of acids in this building, because the off-gassing of acid will eat a roof like this, and so we want to be conscious of that. But otherwise, we'll go through all of this. But what I want to do is I want to go outside and touch on a couple of the important items that we have outside. Within the ComSOP, on both the exterior as well as the interior portion, we talk about docks. Now, when inspecting docks, we have a load leveler, which is here. We do not have to test levelers, but that's what adjusts the height of this floor to the height of the trailer or the truck being loaded from this dock. But what's important to inspect is first the cushions to the wall, making sure they're present. And next is the curtain and the curtain cushion that's around it. While it might not be much, this might be a $2,000 or $3,000 replacement. If you got 30 dock doors, that's a very expensive replacement. And so you would want to make sure that you identify any issues that might be present with the door, the truck stops and cushions, as well as the door cushion that goes across and around the frame. So we want to look for that. Otherwise, as you walk around the exterior of the building, again, we're looking at obviously fogged windows, and then the topography. This is a tilt-up construction, tilt-up concrete construction, and so plumb level, square and straight. Stopping at this corner, looking down this wall and seeing it's nice and plumb and straight. I look down this wall to make sure it's square, and you'll find you're going to want to do that on all of the sides of the building. So we'll do that now as we walk around the building. Being always careful of where you're walking. We have a hose hydrant here. With the water being off, I am not going to turn that hydrant on. We do have a small curb here. They've got a nice yellow line, which is nice for safety. Because we've got a spot here where we've got exposed reinforcement, which is rusting, and this damage that is present here, that would be certainly something on my inspection report I want to highlight, because as that rust populates and becomes more pervasive through the rest of this wall, we could lose a bit of the structure of this wall. So that's something that we want to be mindful of and see. Now, what's interesting in this building, if we've walked around the inside of the building, our inside floor height is about here. And as you'll see that carried across the line to the stoops, we did not have a riser up to these doors. And so everything that's happening below us, there's fill on the other side of this, whether it's solid concrete or whether it's a gravel fill. And so I'm watching for bulges. I'm making sure this wall, again, is plumb up and down. We also have another dock door here with an overhead. I've got a small garbage corral that's right here. If I'm worried that the truck can hit the corral, then I would certainly encourage a bollard be placed right here to protect a backing up truck from hitting either into this wall or onto the side of this parking corral. Garbage corral. Then as we cycle around the building, again, plumb level, square, straight. I've got some more expansion cracking going on here. See, this is crumbling. I'm sure there's rust. That rebar is expanding because of the rusting, and it's causing all that concrete to scaff away. So that is something that we want to note. With tilt up, we also have this mastic seal that's here. It's usually pretty pliable, and so we want to make sure that's intact. If it's not, we want to note those deep cracking. This looks actually quite satisfactory. And then we have our most likely VIP parking that goes across the back side of this. This was the employee break room that we were in inside. So I would, again, watch for these seams. I've got all the roof drainage that comes down. So I always try to put myself into a position of, if I'm draining off of here, where does the water go? And in this case, the water looks like it's flowing downwards through the parking lot, away from the building, and over to along the curb and gutter. And right over here at the corner of that gutter, I do have a catch basin to catch the water. So we are dewatering this parking lot pretty well. I've got the same cracking going on here. So in this particular case, I think it'd be a very appropriate thing to tell your client that you might want to recommend getting somebody in here that's a waterproofer, a damp proofer, or a tilt-up concrete expert to make sure that these corners are solid and they're structurally sound. They might have to take and peel off some of this to do a proper repair. But right now, we've only looked at 3 corners, and all 3 corners have the same problem, one a little worse than the other. So certainly something to be mindful of. Here's our downspouts. With downspouts, and again, this has been hit by a car or a snowplow. You can see how it's bent over like this. It's actually pulled away from this fastener that's right here. If the cars are migrating through here, again, this would be a great spot for a bollard. A bollard would prevent somebody from hitting the wall or hitting this. The reason these are open downspouts like this is for maintenance, that prevents any debris from clogging up, icing up, and causing the damage to the downspout. So it really becomes a very effective means of control. As we look at the fenestration or the windows of this building, you can see where some of our drip edge is missing sealant. But beyond that, on these window gaskets, especially right here, our gasket is shrunk. And that shrunken gasket will allow moisture to come down this glass, enter here. That moisture will either be able to evacuate from here, go into the hot building, or cascade down this wall. Either way, it's not where it's supposed to be. So you want to make sure that on these windows, this has got a large gap, that's got a large gap, this has got a large gap. You can see where it's all shrunk. And so you would recommend on your report that you probably will need to have the windows resealed to make sure that they don't allow water in. Again, topography looks good. We've got 2 wonderful bollards here. They are placed in to either protect the bikes or protect the building. We've got a nice bike rack. But then when we come across this part of the building, we've got all this landscaping. We had talked about the elevation of the building being right about here. Well, you can see the soil is up higher than the floor of the building. And so I can't guarantee that we've got waterproofing behind this. And so my inspection will include a photo of this planting box and recommendations of waterproofing that side of the building. In fact, we've got irrigation here. That irrigation is broken, which is beyond our scope, but it's pointed right at the building. So all of that is areas that we can hydrate and cause issues with the building that we want to watch for. Steps. Steps require hand railings. We are not the authority having jurisdiction, but we can make all the recommendations in the world. I've got 1, 2, 3, 4 steps leading up to the building, but not a hand railing. There should be a hand railing on both sides of this. Even with that landscaping there, somebody needs to be able to hold a hand railing to get up to the building. And so we would want to be mindful of that for safety for sure. During the exterior of the inspection, you would have tried to turn on the exterior lights. That would hit these pedestal lights that we have across this well here, as well as any of the down lighting we have with the pot lights under the building, or any building lighting we might have around the building. If you don't have access to that, then you want to document the lighting right now and say lighting was not tested due to a timer or couldn't locate the switch, etc. But you do want to have mindful of that. Depending on the age of the building, even these 2 steps would require a hand railing here and a hand railing here to get up. Not necessarily a guardrail on that side, but you should have a hand railing to get to this space. Now within this sunken area, this is an employee exterior lounge area. And when you're looking at it, we do have a suspended wooden seat area. Well, this wooden seat area actually is quite deteriorated. It's completely rotted and all the fasteners are gone through this. And so a documentation of this, while you might not think it's much, I mean, pennies equal nickels and nickels equal dimes. And so just accumulating just to let the client know the state the building's in as we speak. Landscaping is also something an inspection has to cover for commercial. We talked about the planter bed. Let's look at the trees. I've got this deciduous tree here, there, and there. These trees are overhanging the roof. They're overhanging the roof considerably. That's dropping leaves, that's dropping debris, that's clogging up the roof. And if there's roof drainage up there, these are all part and parcel to an issue that could happen. So I am certainly going to encourage my clients to consider trimming these trees and keeping them from going over the top of the roof for maintenance of that area. Again, I would look through all of this, hand railings, etc., and then we'll carry on towards the front of the building. We have two things to consider when we look at the exterior of the building. One is barriers to accessibility, and that's being access to the building. That's things like curb cuts and areas like that, where if I had somebody that parked here, do they have access to the building? Well, if I look all the way across this entire space, I don't have any ramping. So anybody that is in a wheelchair or limited mobility will not be able to make it up this curb. So I'm hoping the other side of the building is where the designated area is, but there would be a barrier of accessibility on this side. The second thing would be thinking of trip hazards. And when I think of trip hazards, I think of anything, if we're doing an accessibility inspection, that's greater than 1/4 inch. But certainly anything as big as that 1 inch is a trip hazard. So this would be a spot that would catch a foot. This would be a photo I would take and talk about the trip hazard in the concrete. So these are things that we must consider, and that will be certainly on my report. You know, watching my landscaping. So again, we're going to walk through the building, looking at all the fenestration, watching all the sealant. We've got the cut here. And this cut is opened up because of the roof drainage that's coming out of it, or the topography drainage that's coming out of it. And I've got a pedestal light here that would be tested with the tester from inside the building. Again, I'm going to talk about all the exterior lighting not being tested because of the timer and not access to the timer. It's a locked condition. There's the front of my building. So from this front of my building, I am peering that way across the parking lot, and I don't see where there's delineated handicap parking. So if I am worried about in section 6, the life safety section or the exterior section, barriers to accessibility, I think we absolutely have a barrier to accessibility. I can't get to this door from the street. And so that'd be something that we want to be mindful of. But it looks like we're going to not hold water. It looks like all the water is draining off of it. So we've got that identified. And we'll carry over towards the rest of the building. Looking again for trip hazards. Lighting. And we've come to the gas meter. This particular gas meter is a large industrial gas meter, and so the gas would come up from the ground, go past the pressure regulators, through the meter, and then through the building. You'll see the gas valve, which is the red handle, is actually in the off position. So again, we didn't test the HVAC. We didn't test it because thermostats were off. We wouldn't have been able to run anything anyway. The gas is off. So identifying that and taking a photo of that would certainly be on your report, but this would be on my report for sure of where the gas meter is, but then there's my shut off there. On the other corner of this, I do have the fire department connection. That, if you recall from the riser room, is where the fire department hooks up. I'm being mindful that both of the connectors have cover plates, so I don't have to worry about anything being inside. And again, to reiterate, here we are on this side of the building, and I do not have an accessible ramp. And so this building does absolutely have barriers to accessibility. And these are things that you will definitely keenly place on your report. So I guess the best advice I have as an inspector is to go through the building. Do a really good preliminary walkthrough. Know the building, know what you're looking at. Then walk the interior. Take it place by place. If you're newer, then take it system by system. But whatever it is, at the end of your inspection, you should be able to stand back and say, I've seen it all, I've identified it all, I've documented it all, now I can write my report and produce a professional report based on the conditions that are present, and I've observed them all. Good luck on your inspections, and make sure that you walk through the entire building. We've completed all of the exterior and interior portions of the inspection, and this inspection was a little dynamic. We're doing the roof last. I know it's counterintuitive, but given the access to the building was limited, it was best for us to give the roof our last bits. And so we've come up from our installed ladder, and now we're going to continue through the roof. As we walk through this roof, it's a pretty big building. Remember, it's 40,000 plus square foot. We want to walk as much as the roof as possible. And in walking this roof, immediately we identify the roof type, which is EPDM. It's a ballasted EPDM, which means there's rocks. These rocks have to be smooth rocks. As you see in this video, we actually have two different types of rocks present. We have large rock, which is a good 2-inch plus, and then we have small rock, which is 1 inch or less. Whole idea with the ballasted roof is the ballast needs to be everywhere. Second with the ballasted roof is we can't see anything, which is to our benefit because there's not a whole lot we can comment on other than the fact the roof is not going to be visible. But the areas that are visible, that's what we're going to want to pay attention to. Primarily the roll up on the parapet. So let's start with that area there. It's a Carlisle brand EPDM roof. We know it's EPDM because if I scratch it, it leaves that white scratch mark. That's the easiest way for me to tell EPDM versus TPO or PVC. There is white EPDM, there is dark PVC. So like I say, I like to scratch it. And so this gives me a good look at it. When I'm watching this, I'm going to be watching the parapet, I'm going to be watching the coping, and then one of the comments I'm definitely going to make is the fact that all this coping is sealed. Sealing the coping is not part of the normal practice of the installation. So by sealing it, that tells me that they've had a repair done. This building is over 20 years old, so I'd expect some repairs. So we're going to have to watch our drainage, we're going to have to watch our coping, and we're going to have to watch those areas of the EPDM that we can see. Our drainage is a scupper drainage. We saw that walking around on the lower level where we saw all the discharge points from the gutter line. But on the roof, we want to watch all those scupper points. And our first scupper point will be down here. But I try to walk as much of the roof as possible, making sure that my gaze is what my gaze is. On a roof like this, maybe I can see 10 foot. I will tell you on an EPDM roof that's been ballasted, you're not going to see anything. So don't be afraid to widen out a little bit. And where if a normal EPDM that's not ballasted, you're looking every 10 foot, there's no reason why you couldn't look 20 foot on this. So we'll walk over here. I have this upblast vent here for one of the units downstairs. But what I see is all this sealant, and all this sealant here. This would be a photograph in my report to show a repair. Plus there's no ballast right there. So this has definitely been repaired, and the rock has not been introduced back on. So definitely something you want to note on your report. So then when I look at this scupper that's right here, you can see all of this identifier from the repair. Excuse me. And on this has all been redone. So this is definitely a photo and definitely something you're going to place in your report. most likely we had some form of leakage. We did not see any leakage on the inside, but this has definitely been repaired. As you can see in this roof, we've got an upper basin and a lower area, and they coincide with the two halves of the building. Remember, we had office space over there, first warehouse, and then large warehouse towards the back. So we'll do up here first before we do the lower area second. And you can do it, again, all at one time, or you can do the roof, then the vent, then the HVAC. It really depends on how you want to do your process. We're just going to organically walk around the whole roof. They do have, which is really, really nice, these concrete walking platforms. The walking platforms aid in maintenance. They aid in making sure the foot traffic is contained. And it's also safe for the employees because they can walk this roof without tripping and falling on the ballast. This ladder that goes to the lower area has been sealed as well. So I think if this was my inspection, which we're doing right now, I might take 50 to 100 photos just up here, just to have ready so that when I go back to my office to write this report, I have enough to tell the story. And that's really the most important thing, is you got to be able to tell the story. Our gas pipes up here were once coated. The coatings failed on them. And so having the coating failed on them does mean that they really should be recoated. I don't bring a gas meter up here. I don't use gas meters very often, but I would try to smell to see if I smell gas leaks or any gas. But we'll try to identify that as we walk. We do have high pressure gas through this whole building. We know it's high pressure gas by way of there's regulators on all the gas appliances. And so what they're doing is they're dropping the pressure down as we go. So we'll walk this way. We'll probably take a little pause here so we don't have anybody trip and fall, but we'll catch this up right on the other side of this unit. So some more repairs. I think we could almost say there's a blanket repair on all of the intersections of all the curbing. The curbing is where the HVAC is going up. Some large repair here. Again, some more delineated repair with some chalk. So definitely a roof that has had maintenance done on it, and definitely something we want to take a look at. Now, what's fun on this roof for an inspector is we've got a lot of ventilation, a lot of updraft or upblast ventilation, but we do have two utility set vents. That's here, and there's another larger one on the other side. But what's nice here is we can talk about this. Utility set ventilation is a higher centrifugal fan than a normal upblast would do. And so it's got a large fan apparatus here, drawn up and blasting up and out of the building. We do have electric we want to take a look at. We do have sealant that we want to make sure is in good shape. But beyond that, there's nothing to take apart. There's nothing we're gonna go inside to inspect. And again, this is a vacant building. These systems are all shut down, including the HVAC systems. So the operating is not going to be done. Make sure you disclaim that on the report. But this is a utility set vent. Some more chalk marks on our parapet, some more sealant on our coping. As you're looking at the coping, you see some self-tap screws. These self-tap screws with grommets are what hold the coping to the parapet. So we're making sure that those screws are intact, the grommets are intact, that they're not backed out, or the grommets haven't cracked and failed. That's probably the most common thing we're going to find with the self-tap screw, is those grommets failing. It's the same grommets that we're going to find on a steel roof. And so that's what we're going to watch for as we go through here. So I'm in my eye watching all the parapet and all the coping. I'm looking at the drainage, and then I'm watching the roof as we walk. It's also important as you walk this roof, even with ballast, you're trying to look between the rocks to see if there's any standing water. Remember, 20 feet by 20 feet by 1 inch of water is 2,000 pounds. That's a lot of weight. So one rock deep of water would constitute a pretty significant amount of water. That's what we're watching for as we walk through here. It is always tough to walk on these river rocks. Another scupper. And given the rocks and given the amount of movement there, we're not going to get too close because we don't want to fall. Over here, this particular device is a photo sensor. My guess would be is that photo sensor is probably attached to the exterior lighting to make the lighting come on and off by means of when the light is, or when it's light or dark. But not necessarily, but that is a photo sensor. It's just electric conduit junction box coming up with the photo sensor on top. I think as we come around here, we're going to find a lot of these Restroom packaged units all around the building. So why don't we just stop right here and talk about this? On all packaged units, I begin with the premise that I'm going to take a minimum of 4 photos. I'll take one on this angle to get this side. I'll go to the opposite side, take one. I'll go to the opposite side, take one. I always take a photo of the disconnect and a label plate. And so here's our service disconnect, and our label plate will be on the other side if we can find one. Now, what's very interesting in this building, and it's going to be tough for us to illustrate on this video, is I've got this Restroom here, I've got that one there, and they're both trunked into the yoke that accumulates here, and then that goes into the ductwork that's over there. So these two units work in tandem. One is called 4 and one is called 3. It's very important that you label everybody by what they're described as. This is 4, that's 3. It's written on the unit. It's either written right here, it's written on the side of the unit right there, and so we want to identify them by what they are. These units have about a 25-year lifespan. So these are original to the building. These are statistically beyond their useful life. Something you're going to let your clients know. If we had gas to the building, if we had thermostats that were on, I would operate these. Since we don't have gas to the building and we don't have thermostats that are on, I'm going to note their presence. I'm going to note their numbers. I'm going to get their model and serial number if I can get it. And then beyond that, I'm going to tell my client that these are statistically aged out. We'll take a look at this unit that's right here. This is another packaged unit where those are heating units only. This unit is heat and cool. I do the same thing, photo on all 4 sides. On this, I have a GFCI. We do need to have a receptacle for every unit, or within 25 foot of every unit. So if I've got this receptacle here, I can service those 2 Resnors that are over there, which is fine. So they don't necessarily have to have a receptacle. But this is GFCI'd, which we want, but it is missing its weatherproof cover. So that will be something. Now on these units, this is our flue discharge here, and this is our condenser side on the top. The one thing we always got to be mindful of is whether or not it's got a condensate trap. These things do have to have a condensate trap. That'll be on the other side. None of these access ports are accessible. This is the electric section here. This is the condenser or compressor side here. On the other side will be the filter array. To open those up does require dismantling, does require the removal of screws, which is something that's beyond the ComSOP. You can, we're not going to tell you that you can't do it, but most inspectors do not remove the cover plates. Again, statistically, this is a 25-year life appliance. So identifying that is a carrier unit, identifying the model and serial number that is right here is really all that we need to do. And that's all that our client is really interested in, and especially them knowing that this is beyond 25 years. That's the critical element. Let's see if I can see that condensate. Here it is. Here's our trap. So that is present. This is our filter chamber, by the way. This should be, the filters in there should be replaced quite frequently, quarterly, biannually, whatever the maintenance is. This is our large utility set fan. Much bigger than the other one, but it works exactly the same way. Same centrifugal fan. It blows counterclockwise, drawing up from the space and out through the top with our blower motor and everything in back. Looking at the electric, look at the base, and again, if the power was on, we'd fire it up. But if that's a utility set, then next to it is another upblast fan. That's what this is. And the upblast fan, the fan unit's here and it's just drawing up. And so where the utility set can bring a tremendous amount of force, this brings a lot of force, and the smaller ones might be an inline fan or just a small fan that you might have in a restroom. Because this was a manufacturing facility, that's why we have so many fans exhausting from so many different locations. And all of these need to be identified and should be noted on your report. So that would be a fan photo of everyone and an operation if you've got it. But we do have a newer RTU over here that we should talk about. So let's walk over there and take a look at it. This is a newer rooftop unit or packaged unit. Specifically, it's a Carrier. It's a 2019. We can tell that through the serial number. It's got the same serial number sequencing that you would have on just about any type of Carrier unit. What's nice about this, it's huge. Absolutely gigantic. You can get the size if you do the RLA calculation. Not necessarily important that you have the size, because we don't do sizing, but what you want to do is know the age, the type, and the fuel source, which is electric and gas. Electric for the air conditioner, air conditioning, and gas for the heating. We do have filters arrays in these. We do have the burner assembly in here. We have the gas, but remember, this unit had to get craned up here. And if your client was long, you'd tell them that this is a beautiful brand new unit. It looks like it's well installed. All these other units that aren't as new will need to be replaced in the coming years and most likely have to be craned up as well. And so that's going to add to the cost. This unit was probably significant in the cost. I would say in excess of $25,000, probably closer to $30,000. So it's a pretty tremendous unit to look at. Photo the sides, photo the label, make sure that we do have a service receptacle. This side is our economizer and our air intake. So I would want to make sure I look at all of the fins that are underneath here. I make sure we do have a receptacle. This is behind a weatherproof cover, which is what we want. I make sure we do have a condensate that has a trap, which is what we got here. So everything seems to be in good visual order, and that's the most important part. Again, thermostats are off. I can't turn these on, but I can take a look at all of them and make sure that visually all the elements that we need are present. The interesting thing about these newer Weathermaker Carriers is the fins are beautifully protected behind the steel shroud. That prevents any hail damage. In Colorado, where we're at here, hail is a very common element. And so this keeps all the fins from being damaged by hail. As we go down into the lower units, we'll look for hail damage. But up here, so far, we haven't had any cooling units. So we want to make sure we have that in our lines. Other than that, we'll go back where we stopped. I'm going to note the chalk marks on our scuppers, the sealant on our parapet. Again, with the ballasted roof, there's not a lot for us to see, so we're going to disclaim most of this roof for our clients. That's why we're not down here crawling on our knees or getting really, really tight with it. But the rest of this upper area has one more HVAC unit, which we'll do again. So let's go down to the lower roof and begin there. We're down here in the lower area. if you really did your research and really looked at the building before you got here, you'd have noticed and knew that there was going to be a ladder way to get down. There are some of these buildings that don't have that. So really pay attention, because you get down to a space like this. Most of us can get down, but we can't get back up. This is as high as I am. So safety is always important. So do your research and make sure you've looked at every building carefully. So we did. We knew there was a ladder. So now this gives us another great look at the EPDM, some of the repairs, the gas lines. A lot of this is going to be exactly like we did on the upper roof, except just down here. So we'll just continue our walk through here, paying attention for moisture, paying attention for standing water, and then noting all these repairs. Our client is not going to be looking for an itemized list of the repairs. They're going to want to know repairs have happened. So there's a difference between I've noted one repair and there are many repairs. So on my report, I'd have a picture of 4 or 5 of these. Then I'd say all of the scupper openings have been repaired and many of the seams have been repaired throughout the EPDM parapet wall. I would also say that all of the coping has been sealed at the seams, and then I would preface all that with continue to monitor and keep well sealed. That's what our clients need to know, and not here's one, here's one, here's one. So think about this as you're writing your reports, that our clients are knowledgeable. I would note here that this chair is not under the gas pipe. So that makes this gas pipe free hanging and resting directly on the parapet, which is going to cause a braze. And so I definitely would note that. This would definitely be a picture for my report talking about how that chair is not underneath the gas pipe, because we want to make sure things are well supported. And again, lots of upblast ventilation through this whole building. And again, we see the fact that they have been repaired, that they have noted about all the caulking that needed to be done. And so we want to also note those as well. Now what's interesting here is a little bit of change in our roof drainage. We've got a built-in drain here. And that built-in drain goes to a catch and goes through the inside and then discharges through the outside of the building. And then above the built-in drain, a good 8 inches, is a hole through the side of the parapet wall. That hole is there as the emergency relief just in case that drain is clogged. Well, that drain is clogged. We have all that organic matter around the drain. So it's very important that gets kept clear, but we want to note the presence of both of those because that's something our clients are going to definitely want to be aware of. And again, watch our chairs, watch all this, and then we see out in the distance, we're going to see all of that debris. And so that's going to be something that's going to be interesting. But before we do that, I want to talk about our HVAC. Doing the HVAC in this inspection, we noted that wall of thermostats. We noted the wall of thermostats and the other thermostats in the IT room. So I am going to be providing a schedule of all the HVAC, which means it's basically a spreadsheet. All the models, the serial numbers, the ages, if I got them, the fuel source, gas, electric, and then I'm also going to note any remarks of deficiencies that are visible and recommendations. And so all these would be placed on a schedule. And down on this lower roof, we have 5 HVAC units. On the upper roof, we have 4. And so all of those need to be placed in an organized manner. And I like to organize by a schedule. So let's go over to this first HVAC unit and see what we see. So this old unit here, I've got the air intake on that side, which probably is the economizer. That fin unit is completely damaged and no longer functional. I've got the screening that's protecting the fin system. That's loose and damaged as well. Our electric is without function, but it's also without a weather cover. And so we want to make sure that that receptacle is with a weather cover. I come over to this side, and I try to identify my label plate, which is faded and gone. But then I see fuses laying down here on the ground. The fuses would tell me that we've had periodic issues with the electric on this unit. Either the start or something. Not our problem to know why. Our problem or our concern would be there are fuses laying here on the ballast. And so definitely something I want to talk about with RTU number 5. Then on this side, I want to make sure that we do have a condensate, which we do. Here's an interesting thing for us, is we do have a label. That label is tremendously faded. It's almost unrecognizable in locations. So what do you do in a situation like that? What I do is simply say that it's faded and just move on. I'm not gonna do anything beyond that, but I can try to get my best. I can read a 94. So this is original to the building, 1994. And so if I can see this one, then I would assume every other one that looks like this will be 94, which is congruent with what we saw on the Resnors above and the older units above, but different than that brand new Carrier that we saw that was a 2019. So with this, we'll move over and let's go take a look at that debris, and then we'll come back and look at a couple more HVAC units if there's anything important to look at. Otherwise, I would have taken an inventory on every one of these and looked at them each in depth as I did my inspection. All of this pine straw that is here provides opportunity to do a couple things. One, the organic is constantly degrading, and that degradation is going to cause organic matter to start growing on the roof. So it becomes its own bio area. Next, the drain is completely encapsulated in the straw, and that encapsulation of the straw is going to prevent it from draining. And then lastly, we've got the rust and anything else that's going to happen because of that. So watch all this organic matter, make sure we're draining. You don't have to go over there and push it all away. In fact, I wouldn't. I don't know what's nesting or roosting, depending on where you're at in the world, but definitely something I want to note. On the exterior, we already noted the fact the tree needs to be trimmed. This just gives corroboration why it needs to be trimmed. In our IT room, we have a small mini split heat pump. This is the condenser side of the mini split heat pump. One of the first deficiencies we see is the lack of complete insulation on the suction line. That lack of insulation is going to limit this unit's capacity to heat and cool. It is going to freeze or not provide the proper operation. So we definitely want to note that. Our model and serial number are typically located on this unit. In this case, it's over here next to the electric. Make sure it's plumb level on this. It's got a good base to it, and the electric is intact. A lot of this liquidite, as it ages, starts to crack and peel, and sometimes it can actually crack and burst open. So that's something we want to take a look at. So here's our mini split into the IT room, another upblast. We'd have the continuum of everything else as we go through here. But I do want to take a pause for a moment and look at the next HVAC unit. I know this looks hilly and nilly, but this is how I walk around the building. And the next unit I see from this angle gives us really the best view of an economizer I could describe. So on the far left, the square area is the economizer, and the top is the fresh air intake. You can actually see the louvers into that economizer because that opens and closes based on temperature and the amount of air that needs to be drawn in. We don't want that tremendous amount of air being drawn in the wintertime in Colorado because that might freeze the compressor or any of the other components, especially the condensation on the inside of this unit. So those economizers need to have the ability to close in the wintertime. So that's what we're seeing there. But from this angle, this is a great angle of that. We'll go over and look at this RTU number 1 next. With RTU number 1, As we look around us, it's really the orphan to everybody else on the roof. And as the orphan, we definitely want to make sure it's got a receptacle, which it does. The power is off, which we know. Here's another great look at what Liquidite does over time. The entire shroud on this electric has peeled off and failed. So this is certainly something that we're going to want to note on our report. And they should consider replacing that section of conduit for sure. But again, I'd have a photo this way, I'd have a photo that way, and that way. But then I would also want to look at any true deficiencies that we have going on, which I don't see any visual true deficiencies other than age. And again, an age, this is a Carrier, this is a 1999 Carrier. And so it is not as old as the 94, but it is still statistically at or beyond its useful life. Another drain, some more parapet wall, and then another tree with a lot more organic. So these are things that as a visual inspector, we should be catching on every inspection. It's stuff that the clues are here, the cues are here, everything is here for us to be able to describe these conditions, and we don't have to do a lot to do it. We just got to be aware and visually see all of these things. Let's go take a look at another one of these HVAC units, especially one of the ones that's in between the 94 and the 19. This unit here would be an excellent one for us to talk about. It again is a Carrier. Here's our model and our serial number. We do have the economizer, but here's all the information we need to get everything every information for our client. It has had its fuses replaced just like the other ones, so we are having issues with the unit. So we see the 3 fuses here that were used to power this unit. I would assume they're not here because they're powered down. I would assume they're here because technicians don't carry these around in their bag. After they replace something, they just discard them. Do want to make sure we do have a receptacle, which we do. We do have a disconnect, which we do. We do have a condensate. And then, again, this is a larger unit, so it does have 2 condensers, the 1 exhaust. When we're looking at exhaust, and we're looking at these units, we're not supposed to have these within 10 foot of an air intake. And so that's what we're watching for. Not that one, because this is its own and it's out in the atmosphere. But if I had, let's say, the upblast unit, I can't have an upblast unit within 10 foot of this air intake. If I saw that, that would certainly be something I want to talk about. If I had a bath vent fan, that's certainly something we want to talk about, because those can't be within 10 foot. Otherwise, we're drawing in the exhaust that might be coming from the back of a toilet or some other drain discharge. So, kind of summarizing, my report would have had a summary of a schedule of all the HVAC. They'd all be labeled. I would try to produce my schedule in order 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but I would not necessarily be inspecting in that order. I've always done my schedule through a spreadsheet, and I carry the spreadsheet with me on my handheld device. That way, whether it's my tablet or my phone, that way I can put all that information up here and not do it back in my office. But I would have done that for all of these units. Again, I would not have run these units. The power is off on them, and the gas is off as well. So that would have prevented me from doing a good operation. I would have walked the entire roof. So with these, people ask me all the time, so how long would this have taken? This up here on this roof would have probably been well over an hour, possibly 2, to do a thorough job. So on a hot day, bringing water is important, staying hydrated is important, taking a break if you need to take a break. You know your personal limits. But I would have definitely been up here between an hour and 2 hours to get everything I have done. With that, let's finish up, not back on the ground, and we'll kind of conclude this inspection. If my clients were present, I'd probably go grab them right now, spend a couple of minutes, and summarize what I found. If they're not present, then I would want to make sure I do one more quick walk. If I could inside, it's all locked up inside because our host left us. But I would walk around then one more time outside, just to make sure I's are dotted, T's are crossed. If they're present, I'd have talked to them about working space, all those things that might have been in the way. I talked to them about the dual mains that we have, and they're not labeled in this building, the ballasted roof, the previous repairs, and frankly, the aged HVAC equipment that they probably need to get on some form of plan for replacement or anticipate replacement. I don't know how long they're going to be, especially with the fact that they're all off during the inspection. Beyond that, I'm going to go back to my office. I'm going to write this report. And for me and my software, I'll have this report to my clients tomorrow morning about coffee time. Till next time, stay safe on your inspections.